Hello, today's lesson is about writing polynomial functions and finding the zeros using the factors. So let's go ahead and get started. So before we get started, we do need to go over some vocabulary. Now first, I want to talk to you about roots, zeros, and solutions, which are really all the same thing. We say that the variable r or the number r is a root or zero or solution of a polynomial p of x if p of r is equal to 0. In other words, if r replaces all of the variables in the polynomial, then it's equal to 0. Now, what are factors? Factors are numbers and or expressions that we multiply together to get another number or an expression. Now, you are very familiar with these. For example, 2 and 3 are factors of 6 because 2 times 3 is equal to 6. 2 and a and b are factors of 2ab because if I multiply 2 times a times b, I get 2ab. And then finally, one that you are very familiar with lately is the idea that I can take two expressions and multiply them together. For example, if I multiply x plus 1 times x plus 2, I get x squared plus 3x plus 2. Therefore, x plus 1 and x plus 2 are both factors of that quadratic expression. Now here's a little more vocabulary, and this is something that you may not have heard before, this word degree. Now in this context it means something different than it meant in geometry. In algebra 2, when we're talking about polynomials, the degree is the biggest exponent. So go look for the biggest exponent. That's the degree. Among other things, the degree represents the maximum number of possible roots. That's why it's important. So that polynomial above has a maximum possible number of roots of 3. Now, it may have no real roots, or it may only have 2, or it may only have 1, but the most it can have is 3. So, the other reason it's important in this lesson is that if we give you 2 roots, that means you're going to get a polynomial with the degree of 2 maximum. You're not, if you get an answer x to the third, then you did something wrong. And this last vocabulary, something else new, is this idea of multiplicity. Now, what is multiplicity? It's how many times a number is a 0 for a polynomial. Now, here's my example, and I color-coded it. I hope that helps you. So given this polynomial, one of the roots is 5. It has a multiplicity of 4. Now, it's not a coincidence that the exponent on that expression, x minus 5, is 4. The next expression, x plus 2 to the third, has a multiplicity of 3. Again, note that the exponent represents the multiplicity. Now, let's get into what you're going to be doing in class today. Now, given the roots, you can write a polynomial function. Now, how? Well, if you have the roots, you're going to work backwards to find the factors, and then you're going to multiply the factors to find the polynomial. So let's get right into some examples. In example number 1, you have the roots x equal 1 and x equal 2. So let's work backwards with each of our 2 roots. I start with x equal 1. I'm going to subtract 1 from both sides, and I end up with x minus 1 is equal to 0. That is one of my factors. The other root was 2, so I subtract 2 from both sides, and I end up with x minus 2 is equal to 0. That's my other factor. So I have 2 roots, so and now I have 2 factors. I'm going to multiply those 2 factors together, and I used FOIL to do this. So x times x is x squared, x times negative 2, negative 2x, minus x times 1 gives me negative x, and negative 1 times negative 2 gives me positive 2. When I combine my like terms, negative 2x and negative x, I get negative 3x. So my polynomial is x squared minus 3x plus 2. Let's go to our next example. This time I have 3 roots. Well, so I'm going to work backwards on each of my roots, and you can see my work there. You can see that for my root 3, I subtracted 3 from both sides and found a factor of x minus 3. For my factor of negative 2, I added 2 to both sides and got a factor of x plus 2. And finally, for my factor of x minus 1, I added 1 to both sides. Oops, I got a typo there. That should be a negative 1 there, not a 2. And I end up with my factor of x plus 1. Now, I take my 3 factors and I'm going to multiply them together. Now, when I have more than 2 factors, I break up the multiplying them together. So I'm going to start by multiplying together x minus 3 and x plus 2. There's another typo there. That asterisk should be a parenthesis. And I'm going to end up there, after I FOIL those 2 things together, with x squared minus x minus 6. Okay, now that I have that factor, x squared minus x minus 6, which is my first 2 factors combined, I'm going to take that and multiply it by the last factor. Now, I'm going to use FOIL again. So, when I take my first term, x squared, and multiply it by x, I get x cubed. X squared times 1, and I get 1x. Then I move on to the next term in my quadratic, negative x, and I multiply that by x, and I get negative x squared. Negative x times 1, and I have negative 1x. And finally, I go to my last term, negative 6. Negative 6 times x is negative 6x, and negative 6 times 1 is negative 6. Now I combine my like terms. I end up with x cubed. 1x and negative 1x cancel each other out, but I have there negative x squared minus 6x and minus 6. That's my polynomial. Now here's example 3. I wanted to give you an example that includes multiplicity. Now here you're given 3 roots, but the root x equals 0 has a multiplicity of 2. That means I have 2 factors, x and x. So let's look at what I mean. So as usual, I start with my roots and I work backwards. Now I'm not going to go over that in detail this time, but I do end up with a factor x plus 4, x plus 1, and x times x, or x squared. How did I know that? I know because the factor of 0 had a multiplicity of 2. All right, so now that I have that, let me go ahead and multiply x plus 4 times x plus 1. And using FOIL, I end up with x squared plus 5x plus 4. Now that I've done that, I can multiply that whole thing by x squared. I can distribute x squared across my quadratic. So x squared times x squared is x to the 4th. X squared plus 5x is 5x to the 3rd. And x squared times 4 is 4x squared. And that's my polynomial. Let's go on to the second part of our lesson. You can write a polynomial if you're given the factors, and you can also find the roots if you're given the factors. Now how? To write the polynomial, you're just going to multiply the factors together to write the polynomial. Now, we had some practice. That was one of the steps in our previous 3 examples. And to find the roots, I'm going to set each factor equal to 0 and solve it for x. Okay, so here's an example. You get the factors x minus 2 and x squared minus x minus 6. All right, so I need to write the polynomial. So what am I going to do? I'm going to multiply x minus 2 times x squared minus x minus 6. If I have the factors, and I can always multiply them together to find the polynomial, and that's what I'm doing here. And so I use FOIL again, and I'm not going to go through all of that. If you need help with that, you can come see any Cedar Ridge Algebra 2 teacher. But suffice it to say, when I multiply together those two expressions, I end up with that polynomial. Now I still have to find the roots. Well, I was given the factors, so here's what I'm going to do. I'm going to set each factor equal to 0 and solve it for x. All right, so I start with the factor x minus 2. I set it equal to 0. I add 2 to both sides, and I end up with a root of x is equal to 2. Next, I set my factor x squared minus x minus 6 is equal to 0. I go ahead and factor that. I break it down to its factors. I set each of those factors equal to 0, and I solve them for x. That gives me 3 factors, x equal 2, x equal 3, and x equal negative 2. Now that's the end of this video. I do know that you may not have understood what was going on. If that's true, please see any Algebra 2 teacher for help. Don't hesitate. Get help if you need it. That's the end, folks. Have a great day.